it on or anything like that. So today we're going to be learning about how we can use conduction, convection, and radiation to build an effective heating device. It's important for us to know that the heating devices that we see already in the real world use conduction, convection, and radiation so well that they're able to cook something or heat something rather quickly. And so today we're going to be discussing how we can build an effective heating device, because some of you will be joining us tomorrow for our extra credit opportunity to build a solar cooker. Here's what I want to make sure you know from the solar cooker tomorrow. If you're going to participate, you need to be able to cut your camera on so Ms. Neville can watch you work on your solar cooker. You need to be building or testing your solar cooker tomorrow with the class. Some of you have already built your solar cooker, but you'll be testing it, going ahead and putting it out in the sun tomorrow during our class period to get some credit. The other way for you to get full credit is to build a schematic design. And today, Ms. Neville's going to take you through that process of how we build a schematic design. So if the video that I sent out to you was still not very clear or still made everything as clear as mud, hopefully this will be a little bit clearer today. So let's go ahead and get started. You want to make sure you have some colored pencils or crayons with you today. We're going to be making our notes super colorful because there's going to be some things we want to identify in the pictures that we draw today. Okay? If Emma and Kaden would go ahead and cut their cameras off for me, please. Thank you so much. All right, so let's go ahead and get started, guys. We're building an effective heating device, but before we can do that, let's draw this picture of a pot of water, and you can make your soup or whatever, a pot of water that's boiling. As we're drawing this today, not only are we going to draw this picture, we're also going to identify where the different heat transfers are acting on this pot of water. So when we're talking about different heat transfers, I'm talking about conduction, convection, and radiation. As we discuss conduction, convection, and radiation, remember, we talked about how all three of them can occur at the same time on the same object. We're going to see them in three different ways, and today we're going to be labeling how we can see them or where they are, okay? So when I have, let's review real quick what conduction, convection, and radiation are. You don't have your cameras on, but I still want you to put your hands up. This is conduction. Can someone turn on their mic and tell us what is the definition for conduction? What is conduction?
Conduction, direct heat.
Very good. Direct heat on an object. This is fire and this is that object. Please mute yourselves. You want to be drawing this picture, please. Direct heat on an object. Okay? So then we learned about convection. What does the law of convection state? Someone turn on their mic and let us know. Do you need to look back in your notes? If so, go ahead.
Always
Heat will always rise.
And cold will always
sink.
Can someone turn on their mic and tell me why? Why does heat rise and why does cold sink?
The reason why cold sinks because the liquid and gases are related because they behave similar.
So why do cold fluids sink?
Because cold is heavier than heat.
Earth is heavier than heat.
Our cold cold is more dense than heat is. So dense or heavier, so the particles, those heavy particles fall to the bottom, and those lighter particles that are heated rise to the top. Okay, and so then we learned yesterday about radiation. Can someone turn on their mic and tell us what is radiation?
Heat waves.
Heat that travels in waves. We want to remember that with radiation, the particles don't touch each other. With conduction, please mute yourself. With conduction, those particles are constantly colliding and hitting one another, which causes combustion and fire, that direct heat on an object. But with radiation, those particles do not touch one another, okay? So as we're working today, we're going to label where conduction, convection, and radiation are occurring in this pot. And for this, I'm going to use some colors. Okay, the first color I'm going to use is orange. You can use orange along with me. But here we see conduction happening where the fire is directly touching that pot on the outside. That's conduction there. Please label conduction. We want to remember that convection, while that word looks like conduction, it's a very different principle. Convection is talking about fluids being heated and circulating. As Marley told us, fluids are liquids or gases. And so convection heats fluids the best. So when we're talking about convection today, we want to remember that convection is happening inside that pot in the water. There it is. Okay, so that cold water is sinking, and that warm water is rising. Yeah, guys, this is an example of convection, circulating heat. Circulating heat. What's happening inside that pot is convection. Okay. And so with convection and conduction, radiation is what's happening around that pot. Remember, I introduced that word to you, emit. When radiation, emit means that heat is being put off, something to be put out. So radiation is happening with those heat waves we see coming from that pot. So radiation is being seen here as well as heat is emitted from that boiling water.
Are you muted?
I am not, but you need to stay muted. If you cannot hear me, you'll be able to watch the recorded lesson later on. Please go ahead and finish drawing this picture. And label it appropriately as well. Marley, your hand is up. Did you need something, sweetie? Miss Neville is about to go on. We want to remember that if we don't finish getting this picture drawn, just skip some lines, skip some space, and you'll be able to watch this recorded lesson as soon as Miss Neville ends class today. So let's keep going. Let's write this in our notes. Designing an effective heating device. In order for us to design an effective heating device, we must think about what the word effective means first. So it's important for us to know that when Ms. Neville uses the word effective, you'll see that word again, I promise you. When Ms. Neville uses the word effective, I'm really talking about what makes a machine, what makes a device work the best. So when we're talking about building an effective heating device, you don't have to draw this picture yet. You may not have to draw it at all. It's up to you. But I want to make sure we understand some things about how we can make an effective heating device. I want this lesson to help inform you about how you need to design your solar cookers to cook whatever food you decide to cook the best. Okay? So we want to make sure, we're going to write this in our notes. And I apologize for the handwriting, guys. It's the little board I'm using. We want to make sure that we use insulators to trap heat. Remember, insulators don't allow thermal energy to flow through them. They don't allow thermal energy to flow through them. So something like a cotton ball would be an insulator. Where could you put a cotton ball in your, and this is a rhetorical question, I don't want you to turn on your mics and let us know, it's up to you. Where could you put cotton balls or pieces of balled up paper, which is also an insulator, to trap heat in your device? That's going to be super important. We also want to make sure that we use conductors to carry heat. We want to use conductors to carry heat. Where we put that aluminum foil, remember aluminum is a conductor. Remember we did that in our gizmo in class? Aluminum is a conductor. So where we put that aluminum is super important. Could you put that aluminum in more than one place? Sure. Think about where you put it. A lot of times sixth graders think, oh, if I use a bunch of aluminum, it's going to make it really hot. Maybe. It's more important where you put that aluminum. Location, location, location. Remember, if we put our insulators, which trap heat or block heat, in the wrong place, we could hinder the heating of our device. We could stop the cooking of our food. So it's super important to think about where we put our insulators and our conductors. Miss Neville is about to go on, because now we're going to get to the heavy part, the part where we're talking about a schematic design. So today we're going to build a schematic design together today. So you can have one in your notes, for example. You'll also have this lesson in your that you can use in Schoology, so you can go back and watch it. It's important for you to know that if you do not turn in a schematic design to Miss Neville, you will not get that full credit for extra credit. Remember what we're working towards here, and some of you desperately need this. This is going to be 100 that I'm going to put in the grade book to replace your lowest grade. Okay, so you want to make sure that you're thinking about what you're putting in that schematic design, and that you're paying close attention today. I want to save some time at the end of class today to answer any questions you may have that I don't answer during the lesson. I want you to listen to make sure to see if I even answered the question first before you ask the question at the end of class. Today, as sixth grade scientists, we want to practice being effective communicators, and effective communicators don't only speak well, they listen better. I always like to say it like this: we were created with 2 ears so that we could listen twice as hard as we speak. Can you do that with me with your hands and your ears and mouth? We listen twice as hard as we speak. So you may have questions about your schematic design, and that's good, but Miss Neville might answer it today. So listen first and speak second. Kaden, please turn off your camera. Thank you. So let's go ahead and get going with building our schematic design. So when we're creating a schematic design, go ahead and write this in your notes. A schematic design has 2 parts. It has a detailed sketch, and it has an anticipated function, okay? And in order for your schematic design to be complete, it must have both parts. So let's look here. When Ms. Neville is talking about you doing a detailed sketch, this is where you are actually drawing pictures of. You're actually drawing a picture of your solar cooker. So if I was going to draw, oh goodness, it's going to be awful. So if I was to draw my solar cooker, I'm going to draw it with my lid opened. So I've drawn my solar cooker. That's not half bad. Go, Miss Neville. So I would draw my solar cooker here. And when I'm asking you to do a detailed sketch, I'm asking you to include measurements. So how long, how wide and how high or tall is your solar cooker. So you want to measure the length. This is our length. The height. Okay. And the width of your box, and you want to measure it using centimeters. Supposed to be an M. Bear with me. That's centimeters, cm. Okay. In a detailed sketch, you also want to write down, you also want to include a list of materials. So not only did you use tape, you want to tell me how much tape you used. Not only did you use cotton balls, you want to tell me how many cotton balls you used. Okay? So you want to include a list of materials. So that's what you need for the detailed sketch. Okay? The integrated function, pay close attention here. This is the writing portion. So this is where you're going to include 5 to 7 sentences that describe, pay close attention here, how your solar cooker uses conduction, convection, and radiation. You want to write how your solar cooker uses conduction, convection, and radiation. You also want to talk about how your solar cooker uses insulators and conductors.
All I see is just a black screen.
I'm sorry, sweetie. The lesson's being recorded. Hopefully you'll be able to see it then. Is anyone else having a hard time seeing?
No, ma'am.
Okay.
Miss Noble,
Yes.
do you want to draw and write all this?
Yes, ma'am. Okay. So you want to write 5 to 7 sentences that describe how your device insulators, radiation, conductors, and convection. You also want to make sure here, and this is a big one for Miss Neville, because I feel like because we've been out of school for 6 months, we forgot that sentences start with a capital letter and they end with a period or some sort of punctuation. So you want to make sure Miss Neville is not reading TikTok handwriting. Miss Neville is not reading handwriting that's used for social media. I am your teacher, not your social media buddy. So you want to make sure that you're using capital letters and punctuation. All right, now while we're writing this down, Miss Neville's going to take your questions. Go ahead and raise your virtual hand, and Miss Neville will answer each of your questions one at a time. I need you listening. So I may hurt some feelings. I'm not repeating the answer to the same question I've given more than once. So you want to make sure you're listening to how I answer other people's questions, okay? So that I might answer your question from another kid. So I want you to practice being effective communicators, okay? All right, let's get started with our questions here.